Good day, I am Herbert from Series 11, and I will be presenting section A and C in the Seeds of Presentation video alongside my group members. Kyle will be presenting section B, Joshua will be presenting section D, Siri will be presenting section E, and Max will be presenting section F. Section A is the software development source files. As a group, we decided to use GitLab as a version control tool. This allowed us to check the changes, pull down the changes, what time they made changes, and if there was any issues with the changes that they made. GitLab also allowed us to all have a good version of files that were being used, so no one was using any outdated files. We also made sure to use good naming conventions as well as organized file structure. This would mean that the group would be easier for them to identify structures and what folder to work in. We also used branching features and only had one main branch for a single repository, and this allowed everyone to be working on the same files. And this also caused there to be fewer merge conflicts. We also used issue boards, and that allowed everyone to know who's doing certain work, what place they can get at, and it would also allow team members to work on the same problem when they aren't co-creating. And this was very efficient for our group because it allowed each one to know what to do and what time they should be moving on to the next section. So it gave us an estimate of how long each section should take to do as well.
I'm Kyle, and my topic will be on code design and conformance. Firstly, we will look at the specifications of the project, and for this we need to look at several classes. First, we have the database API class. What this class is responsible for is to set up a Javelin server so that we can listen for incoming HTTP requests so that we can interact with the database. First, we have the save. The save world. What this does is that it saves the current world that is in the game into the database. We save the height, the width of the world, as well as all obstacles inside of the world. Up next, we have the restore world. What this does is that it takes a world in our database, depending on the name that we pass into it, and it instantiates that world into our game. Up next, we have world names. What this does is that it dumps all of the names of the worlds inside of our database. And lastly, we have the launch, which is what the client uses to launch into the world using the API. Up next, we have the server class, the main server class. This class has two functions. It starts the server on a particular port that we desire, as well as taking command line imports, such as the size of the world which we wanted to run on, as well as whether or not we want to start the server handler class. Now, what the server handler class does, I do not have that open. What the server handler class does is that it basically takes input from the server side so that we can use various commands like dump, robots, saving the world, and restoring the world. Lastly, for the server at least, we have the client handler. Now, what this class is responsible for is to basically keep track of the clients, as well as making sure that requests from clients are being received, being handled properly, and responses are being sent back. Each client will have their own client handler, since this is running in a thread in the main server class. Lastly, we have the client play class, which is a thread of the main play class. So this just starts up the thread. So what this does is that it's basically the interface, the client. Yeah, this is basically a full client. So as you can see, we have getting the server IP address. In a later demo, you will see how this works. We have setting up planner. We are connecting to the server in this line over here, starting path readers, getting input from the user, proper error handling as well as setting the launch request, which the API actually uses, sending basic requests, making sure that we have different robot types, initializing the robot on the client side, updating the robot after each command, as well as making sure that all the resources are closed afterwards. When it comes to accessing data in a project, we have to look at several classes. First up, we have all of the classes in the database package located over here. First, we have the connector class. The main purpose of this class is to connect to the database, which is the database we have over here. And here is the connection class, the connection function. What that does is that it creates one connection with the database, and it ensures that that connection is reused throughout our entire program. Up next, we have the world DBM. This class is responsible for interacting with the database. We have several methods to do that. We have the add world, which adds a world from the server into the database. We also have the get world, which then retrieves a specific world from the database. It depends on which argument we pass into the function, which determines which world. There are also error handling involved. So if no world is being passed into the get world function, a random world would be selected, and if a world that is not available in our database is selected, we will return an error message saying that the world is not there. And lastly, we have all of the error handling. Closing all of the resources. So we're just closing all of the resources to make sure that no errors pop up. We also have the get world names. What this does is that it just dumps all of the world names that are in the database. The world DAO class acts as a data access object when interacting with the robot worlds table. It uses a robot worlds DAO class, the do class, which I will explain in a bit. This class mainly follows the CRUD method when it creates worlds, retrieves worlds, updates worlds, and delete worlds. So as you can see, all these methods are present. We have also different ways to retrieve worlds via the get by ID, where we can retrieve a world based on its ID or by its name. We also have a very similar class. It's basically the obstacle version of that class, where it does the exact same thing, but just with the obstacle table instead. Next, I will show how the names we have chosen for specific classes and variable have purpose, and it makes sense as to why we chose them based on what each class does. We have a robot class, which stores all the information about the robot, including its name, the number of shields it has left, the number of shots it has left, its state, and its kind, which is basically the make of the model. Next, we have the direction class, which is an enum class, and this simply holds the directions that the robot can face. We have north, south, east, and west. Lastly, we have the command class, which is the class that determines which command has to be run based on the request string we receive from the client. And if we scroll down, we can see here that each command is named according to what they do. So the launch command launches the robot in the world. The fire command makes the robot fire. The look command looks around. The repair command repairs the robot. The reload command will then reload all the shots that the robot starts with at the start of each game. And there was no need to document any deviation, as previously seen, we have met all the project specifications. Stress testing is a type of performance-based testing where we assess how well a system does under extreme conditions. The main benefits of stress testing in terms of our project is how the server handles multiple clients without decay in performance. On the server side, it's how well the server behaves under stress when processing server responses during overload periods. And lastly, world readiness. This ensures that there is a consistent user experience by verifying the reliability of our system under varying loads. In any major software development project, testing is extremely crucial, whether it be in a Greenfields project or a Brownfields project. If you take a look at our source folder, you can see that we have a test directory, that is where we store all of our tests. We have an acceptance test package for all of the acceptance tests that we have. We have the database package with tests for the database. We have the Docker package, which we have tests to run against a Docker image of our project, as well as the unit tests, where it's separated into two subdirectories where we store the client tests, as well as the server tests. So as you can see, we have taken testing extremely important, purely based on the amount of tests that we have. I think in total we have close to 150 tests, and I'll run all of the tests in a time lapse, as it takes quite a while to complete. In our project, the user expected us to do a few things. A client has to be able to connect. Now, number one, connect. Number two, launch. Number three and four, move and look around respectively. Number five, retrieve the robot state. And number six, fire. Okay, so now I will demonstrate the demo. I have a server running locally over here, and as you can see, if the server is running locally, I can just press enter without entering any IP address. So now we are connected to the server, and our first objective is to launch a robot. And here is the method to do so. So now we will launch. Sniper is the type of robot I want, and I will name it Kyle. And as you can see, we have launched into the world with visibility 7. So now I will use the look command to look around, and we can see that we have all these obstacles and even edges close to us. So now I will demonstrate the forward command. So I will move forward 20 steps, and as you can see, we have been obstructed by an obstacle, because north of us, we are facing the direction north, and north of us, 15 steps away, there is a lake. And now I will demonstrate the forward command again, but not too far forward so that we don't enter the lake. And as you can see, our position has changed. We can also turn left. As you can see, now we are facing west because we have turned left, and we can turn right, and by doing so we'll be facing north again. I will now demonstrate the state command. What the state command does is that it gives basic information about the robot, including its status, how many shots it has left, its shields, direction, name, type, name, and its position. Now I will demonstrate the fire command for you. And as you can see, we can fire, and we have missed because there is no other robots present in the world. And now I will use the state command again. And as you can see, the previous time we used the state command, we had 20 shots, we fired, and now we only have 19 left. So that is it. That is all that I need to show, and thank you so much. I will now quit the client. Here we go. In order to run the project, there are a few prerequisites that you need, which include Java 11 or above, Make 3.8, Maven 3.8 I mean, Make, as well as SQLite to interact with the database. To run the program, all you have to do is to navigate to the root directory of the project and enter this command here for the server jar, as well as any command line inputs you want. And for the client, it's simply just this jar, this command over here. Our project overview is in the readme file, which is this project is a multiplayer robot combat game where players launch and control robots in a shared virtual world. Each player maneuvers their robot through a dynamic environment filled with obstacles and challenges. The primary objective is to outmaneuver and destroy the other players' robots while navigating the terrain. Key features we have is multiplayer support. The game supports multiple clients, allowing for several players to connect simultaneously and compete in real time. Robot combat. Players can engage in strategic combat using their robots' abilities to outwit and defeat opponents. Dynamic environment. The game is filled with obstacles that players must navigate and adding an extra layer of strategy to the gameplay. As well as the client and server architecture, the game is built on a robust client-server model, ensuring smooth gameplay in real time and interaction between players. To view the layout of our project, you simply have to go into the source directory on our main branch. As you can see, we have two packages present in here. We have the main package as well as the tests. The tests are where all of our tests are, like the unit tests, where we have tests for the server and client, acceptance tests, tests for the Docker image, as well as tests for the database. And if we go back to the source and back into main, we will see that all the server code is in the server directory, client is in the client, and so on and so forth. Yes, other programs do have the ability to analyze our code. For example, they could go to the pipelines, and then they can see how our code has taken shape over time, as well as using the repository graph. This basically tells a story as to how our code our code structure has changed over time. Many times we have failed and we were forced to revert to a previous commit. And yes, also back to the pipelines, the tests can be rerun. For example, on my latest commit, I can easily rerun this test again. If we go into it, we can see that it is preparing to run again. Unfortunately, the runner is a bit busy, so I can't really demonstrate that fully. But as you can see, the job hasn't started yet. Oh, and luckily it did.
Good afternoon, it's Robin again, back with section C on database management systems. So firstly, I will be talking about the disadvantage of DBMS, or at least the challenges of DBMS. Firstly, the cost, data consistency, data redundancy, and then data security. So when it comes to data consistency, this is where we would want the data to remain the same and it not be constantly changing. Data redundancy is where only one copy should be shared and made. So if you do, however, make changes in the data, this would allow a new copy to be made with different data on it. And then data security, this is allowing people to access your work. They should only be allowed access if access is given to them. And then the key features of DBMS, and that would be data backup and recovery, data consistency, and then data independency. In different types of databases, there are network databases, relational databases, object-oriented databases, and NoSQL databases. So network databases support many-to-many relationships. It allows records to have multiple parent and child records. And then relational databases, also known as DBMS, it stores data in tables. It has relationships through foreign keys. And then a good example of it is it's used for banking systems. And then object-oriented DBMS, and this stores data in objects. A good example is engineering applications. And then NoSQL DBMS, it allows handling of large volume of unstructured or semi-structured data. For our Brownfields project, also known as Robot Tools, we used SQLite. This because it was lightweight and fast. It was ideal for any systems, especially with it being some team members were using Linux Mint or some were using Windows, and it works on all platforms as well. Like I said, this was great for our team personally. And most importantly, it was easier for our team members to understand and learn based on the short amount of time we had to learn about SQLs. And then DBMS in user tools. So there is query tool, that allows users to write and execute SQL queries to retrieve, update, insert, or delete data. And then there is report generators that ensures users to design and generate reports from databases. And then there is data entry forms. Good afternoon, it's Robin again, back with section C on database management systems. So firstly, I will be talking about the disadvantage of DBMS, or at least the challenges of DBMS. Firstly, the cost, data consistency, data redundancy, and then data security. So when it comes to data consistency, this is where we would want the data to remain the same and it not be constantly changing. Data redundancy is where only one copy should be shared and made. So if you do, however, make changes in the data, this would allow a new copy to be made with different data on it. And then data security, this is allowing people to access your work. They should only be allowed access if access is given to them. And then the key features of DBMS, and that would be data backup and recovery, data consistency, and then data independency. In different types of databases, there are network databases, relational databases, object-oriented databases, and NoSQL databases. So network databases support many-to-many relationships. It allows records to have multiple parent and child records. And then relational databases, also known as DBMS, it stores data in tables. It has relationships through foreign keys. And then a good example of it is it's used for banking systems. And then object-oriented DBMS, and this stores data in objects. A good example is engineering applications. And then NoSQL DBMS, it allows handling of large volume of unstructured or semi-structured data. For our Brownfields project, also known as robot tools, we used SQLite. This because it was lightweight and fast. It was ideal for any systems, especially with it being some team members were using Linux. As a group, we decided to use relational database management. This is because of the structured data. Data is organized into rows and columns, which gives the data a more logical way of being structured. For the use of data integrity as well, it enforces data integrity through constraints such as primary keys, foreign keys, and unique constraints that I would be showing in the next slide. It is also used because of data security as well as backup and recovery. So say for instance, data, there's machine failure, there's a minimal risk of your data being lost. And then with regards to key relationships, like I said, I would be showing you in this slide. In the first column, you would have your ID of the robot's names, and this ID is then located to a second table, which would be identifiable based on the objects in this wall. The relationship between the two and the key relationship is the world and then the obstacles, which are both identified based on the ID being used in the rows and columns.
Hello everyone, and welcome to our demonstration. Today we are going to explore how our application integrates SQL and manages data. I'll be guiding you through various aspects of our system, showing you how we've implemented SQL for efficiency and clarity, and how it fits into the overall design. Our goal is to demonstrate how we use SQL to handle data effectively, ensure performance optimization, and maintain data integrity. We'll also look at how our application connects the database with the web interface, and how we've structured our code to be clear and maintainable. So just to go through some of the points that we will be discussing, I would just like to go through the slide that I made over here for you guys. For you. All right, so to make things a little bit easier, I've created a slide deck that just shows you guys what we will be discussing today. And the first point will be implementation of program design using SQL. You are more than likely to go look at the method save and the class server handler. All right, and then we'll be discussing understandable SQL code, optimized SQL queries, SQL code readability, necessity of table joins, some data integrity preservation, methods of accessing data, data sharing within the application, underlying technologies linking databases and websites, linking web packages to linking web packages to back-end applications. Well, and then well-commented code. So to showcase application design and SQL integration, I will be showing you our server handler class. So here's some of the concepts that we implemented in the server handler class. So number one, what we'll be focusing on is the database connection. The server handler initializes a connection to the SQL database using the JDBC connection source. Secondly, the data access objects. All right. So the server handler uses the world DAO and obstacles DAO for SQL operations, managing interactions with the worlds and obstacle tables. Right. Then our save and restore methods over here is used for data handling. These methods prepare data to be sent to a remote server, and the data derived from the world state. That would be the current world state, and it is managed via SQL operations through data access objects. Right. The server handler also practices encapsulation of SQL. The actual SQL queries and database interactions are handled by the data access objects, abstracting SQL operations away from the server handler. All right. On to the next point, which is showcasing understandable SQL code. So you'll notice over here this is an SQL code that we have, and it's written very clearly, so any team member will be able to understand, or anyone outside of the project coming into it will be able to understand. So next I will be explaining how the world DAO class achieves optimized SQL queries. So the method that I want us to focus on now is the getByName method over here. Excuse me. So the getByName method in the world DAO class achieves optimized SQL queries through the use of ORMs like query builder, selective data retrieval using the where clause over there, and potentially leveraging database indexing by abstracting the SQL operations behind an ORM and using methods like query for first over there. The class ensures that the database interaction is both efficient and easy to manage, which aligns with the goal of optimized SQL performance. The next thing that I will be demonstrating is SQL code readability, and the class I'm going to use to showcase this obstacles data access object. So this is going to be the whole class that we're focusing on now, or in particular, we can focus on the getByWorld method over here. Okay, so the getByWorld method achieves SQL code readability through the following approaches: the ORM abstraction, right, and then using query construction, and then using a clear structure, as well as well-redefined relations. And these factors combined ensures that the SQL code within this method is structured in a way that is understandable and maintainable for developers. So the next point that I will be demoing for you guys is the necessity of table joins. And for this example, for this showcase, we will still be using the getByWorld method that's in our obstacle data access object. And this demonstrates the necessity of table joins in the following ways. We use foreign key relationships. I'll just like to show you. Excuse me. Use foreign key relationships in the obstacle to O class. All right, and then we use implicit implicit joins via the ORM class. Via ORM, we use efficient data retrieval. Okay, so this method relies on the foreign key relationship between the obstacle data object and the world data object to perform necessary table joins, and this ensures efficient and accurate data retrieval while maintaining code readability and simplicity. Okay, the next point that we will be focusing on is data integrity preservation, and the class that we will use to showcase will be the world2 or the world data object class. In particular, I'd just like to show you. All right, we can focus on the whole class. Cut. Okay, so the next point that I'll be focusing on is the data integrity preservation. All right. So the world2 class, as we use in the world data access object, specifically the create method, it maintains a high data integrity in the following ways. Right. So we have constraints in the fields. We generate IDs, right, and we have consistent data relationships. We also use atomic transactions, and we also have a data validation. So in summary, the world2 class maintains data integrity by enforcing field constraints, ensuring unique identifiers, maintaining consistent relationships, leveraging transactional context, and utilizing our validation features. Okay, the next feature that I want to showcase to you is methods of accessing data. We will be using the world data access object class to showcase this. So the world data access object class provides several methods for accessing and manipulating data in the world2, each serving a specific purpose. So it's using CRUD methods, which is creation of data, retrieval by unique identifiers, get by over there, and retrieval by name is over here. And we also have update data methods and deletion of data methods over there. Right, so the world data class provides a comprehensive set of methods for accessing data, including creating, retrieving, updating, and deleting records. It leverages the data access object interface provided by ORM Lite to perform these operations, ensuring efficient and effective interaction with the data. So the next point that I'll be showcasing is data sharing and management within the application, and for that, I'll be taking you back to the server handler. So the server handler class facilitates data sharing and management within the application by restoring a world state from the database, and then saving a world state to an external server. It also integrates restored data into the application state. It also handles resource cleanup and effective output for debugging and management. You can see over there. So the next point that I'll be showcasing is underlying technologies linking databases and websites. And for this, we will remain on the server handler class. So firstly, the technologies that we use is ORM Lite and SQLite. The class uses ORM Lite for interacting with the SQLite database. And the world data access object and obstacles data access object, are used to perform CRUD operations on the world and obstacles do tables. This allows the application to store and retrieve world and obstacle data in a local SQLite database. All right, the server handler then uses HTTP communication. All right, and the save method, I can just show you. The save method uses an HTTP URL connection to send data to an external over there. Yes, also it uses HTTP to send data to an external web service. It constructs an HTTP post request to specified URL. Specified URL is HTTP localhost 7000. Say world, for example, and sends the world data in the form of an application. Okay, this is the form it uses to send the data. All right. So then it also handles JSON data handling. It uses JSON object mapper for JSON data handling. All right. So in summary, the server handler class links databases and web services by using ORM Lite to interact with an SQLite database for storing and retrieving data, employing the HTTP URL connection to send HTTP request to a web service, and then utilizing JSON for JSON serialization to format data for the web server communication. And then lastly, I just want to show you our Java task strings. So hopefully throughout this demonstration, you notice that all of our methods and classes have Java tags included. Thank you guys so much for bearing with me during this presentation. I appreciate it.
My name is Lisa. I'll be focusing on section A, which is about assessing test plan execution and database access verification in computer program testing. Before writing the actual code, it is advisable to write the unit test first for accuracy and easy debugging purposes. With that being said, I will show you the test plan for our software program. To showcase the execution of operational steps identifying the test plan. For our test environment, we use the JUnit, which is the JavaScript framework for writing and running unit tests. We use Mockito that mimics the real world or software without causing errors for the actual product. We use in-memory database and socket setup. We use continuous integration pipeline, which is configured in GitLab to execute tests on every commit. Our objective focus on testing the functionality of the software to check if we can deploy the world also on the database and obstacles and making sure that they work as expected. The test plan focused on testing for functionality, meaning we tested for movement commands that include moving forward, backward, and turning of the report. The action commands, which is fire, reload, and quit. The error handling, which handles the error messages and provide us with feedback. We tested for database also to see if we are able to launch the world and obstacles into the database. And those are the objectives of our testing claim. I will take us through the forward command test case just to test the movement. Now this setup method configures the mock calls to return a success response when a robot moves 5 steps forward. The test executes success. If a client input the forward as a valid command, the robot will be able to take 5 steps forward. That is what the exception will do, and we'll get a message response that the robot has moved 5 steps forward. To demonstrate the use of input data as specified in this test plan, we are going to take a quick look at the quick command. This is the quick command. The quick command ensures that when the client inputs quit, they are going to be logged out of the server. Their playing status will be set to false, meaning that they are no longer in the game, and they will get a response also that they've already left the server. They are logged out of the game. For the deviation part, I'll take us through to our slide. To showcase the deviations, I can say with almost surety that we have no deviations in our test. We tested for every scenario and edge case as well. For that, I will run all the tests in the unit, all the unit tests for our software, and they should run without a problem. The test is still loading. Now we are testing for 70 tests in our development. As we can see that all the tests pass successfully without any deviations. Moving on to demonstrate or showcase the standard procedures. We use the POM file or POM XML to verify all the versions and plugins for our software. We also use the direct HTTP link if you don't know the version that we are using. I'll take us through briefly the POM XML file. Quickly to the POM XML file to see all the plugins and the versions that we are using. This is the POM file, our code base. This is where all the magic happens. For showcasing or demonstrating the code's logical path, I will go through the command test class. In this test, we are testing for a valid quit command. When a valid quit command has been passed in, we are able to log out successfully of the game or in the server, meaning we are no longer going to be in the game participating. For the invalid command, if you input the command wrongly or incorrectly, meaning that the quit is QITs, that is what I meant, sorry, or QI, meaning it's not a quit command. You're not quitting, there's a mistake, you displayed your quit wrongly, therefore you'll get a response that the command is not supported. The same goes for the state command object. If you input the state as a command, which is a valid command in our program, then you'll be able to see whether your robot is, if there are obstacles or edges in front of it. You get a state command, and it also goes the same thing happens for the invalid state command. If you write your state wrongly or incorrectly, then the command will not be executed. While we are still showcasing the code's logical path, I would also run all the test cases that we wrote. for the software development. I will run all tests, meaning I'm running the acceptance test, the test for the database, the Docker, as well as the unit test. As a team, we wrote about 120 tests in total. Say 7 out of 20, out of 120 tests passed. We worked together to produce and write all the necessary tests and following the procedure accurately, showing effective use of all the tools and proper test execution. This also helps document code behavior, making it easier for developers to understand the intended function. And without continuous integration, meaning developers can work or input their own feedback without breaking the actual code, as long as they are writing tests. So 79 tests and 80 tests passed out of 120. I see there's one test failing. I will see about that in a minute. The crucial part of writing unit tests facilitates refactoring, making it easier to improve the code base without the fear of breaking the existing functionality, which is why it is very important to write unit tests. Number 10, 19 out of 120 tests have passed. So only one test failed. I will take a look at that in a moment. For now, I'll take us back to our slides. We are going to showcase the elimination of errors through the testing of database access using the SQL. For this, we are going to look at the API test. The API test is under the database. In this test, we are testing for the restoration of the world from the API. We want to verify that the world can be restored successfully and attributes match the expected values. We'll start with the setup. The setup part initializes the HTTP client and database connection before each test. It also starts the API service and allows it to be initialized. We're going to specifically look at the restore world. The asset requires at the restore world checks if the HTTP response status code is 200, which means that the request was successful, meaning that the world was restored. This accession ensures that the API is functioning correctly and returning the expected status. This accept equals final. It verifies that the name which is final attribute is of the restored world object, meaning that our world is named final. And thus, assertion over here, it checks that the world was restored with a width of 20 and the height of 20 as well. So now I will go back to checking why one test was failing and continue with the rest of the test.
Hello everyone. So in this section, we will be discussing evaluating the documentation consistency and design adherence in computer program presentations. So section F deals with documentation, and there are a few questions that we are supposed to cover within this section. And the first one is whether the presentation showcases documentation according to a pre-created design, whether the presentation identifies if the documentation was created consistently with the computer program being documented, whether the presentation identifies if the documentation was created according to the design created in specific outcome plan and design documentation for a computer program to agreed standards. And the last one being that the presentation structured documentation sensibly and define how program specification has been met for documentation for a computer program. So we've set up a way to showcase this section. Firstly, we're going to briefly go through our project documentation itself that we have created for presentation purposes. And we're also going to show you a little bit of our README file docstring snippets, and lastly, the layout of our project. So we have created a documentation file that will be fit for presentation purposes, because we did not want to include the whole document itself, since it is a very big document and it contains each and every detail. But this document contains all of the most important details of the project itself. So this is an example of it, and it has got the title, and it also briefly describes what the document covers. And it's got the project overview, the name of the project, the date of which this project is due, the names of everyone and their roles as well. And this document also covers a primary objective. The primary objective of our project is described inside of this document, and next to it, we've got success metrics that are used to evaluate and also to check whether we are still winning when we are busy creating our project. And after, we've got the timeline. So the timeline is divided into iterations. So we had a total number of 4 iterations, and we had 6 weeks to complete our project. So on each iteration took about 2 weeks to finish, and for each iteration we had our metrics. We had our success metrics as our key as our targets. So for example, for the first iteration, we had to make sure that our project complies with the requirement or the specifications. And so our document also covers some links to what we were using, such as the Miro board and also our GitLab. And we also have got links to our GitLab repo as well. Now, coming to the README file, we actually prepared some shots of how our README file looks like. So the README file is also part of the documentation of the Robot Worlds project, and it also contains overview, key features, and how to run the server and how to run the client side of our project. So the README file also covers architecture, which also includes the communication protocol and the client server architecture. And lastly, the README file also covers the basic commands, which are the client commands. And we also have server responses. And we also cover protocol, serialization, and it also covers whoever contributed, the whole team names of the contributors. And we are now finally going to showcase the project layout, which shows that the project was firstly in the beginning, the layout was just for, it was just a very simple layout. And by actually following the documentation, we actually kept on adding. And so that's how it became a much broader layout, as you can see on the second picture as well. So this just proves that our documentation is actually in line with how the project was created. The team followed exactly what the documentation entails when it was pre-created. Thank you very much.